In our previous episode, we talked about atoms and their basic properties. Today, we are going to introduce you with the group of atoms when they come together and combine make a new substance called molecules. Hello everyone, welcome to the show. I hope you are doing well. Let's begin the show. A molecule in general is a group of two or more atoms that are chemically bonded together, that is, tightly held together by attractive forces. In a more specific way, a molecule can be defined as the smallest particle of an element or a compound that is capable of an independent existence and shows all the properties of that substance. Atoms of the same element or different elements can join together to form molecules. When the molecules of an element are constituted by the same type of atoms, known as molecules of element, these molecules can be divided into four categories. First one is monoatomic molecules. The molecules of element which are constituted by only single atoms are known as monoatomic molecules, such as argon, helium, etc. These are made up of only one atom of that element. Second one is diatomic molecules. The molecules of element which are constituted by only two atoms are known as diatomic molecules, such as molecules of oxygen and molecules of hydrogen. These molecules are constituted by only two atoms. Third one is tetraatomic molecules. The molecules of element which are constituted by four atoms are known as tetraatomic molecules, such as molecules of phosphorus. This molecule is constituted by four atoms. Fourth one is polyatomic molecules. The molecules which are constituted with more than two atoms are known as polyatomic molecules, such as molecules of sulfur. This molecule is constituted by 8 atoms. The number of atoms consisting a molecule is known as molecule's atomicity. Hence, we can say that atomicity of argon is 1, atomicity of oxygen is 2, atomicity of phosphorus is 4, and atomicity of sulfur is 8. When atoms of different elements join together in a definite proportion known as molecules of compounds, such as molecules of water H2O are combined in the ratio of 1:8 and molecules of ammonia NH3 are combined in the ratio of 14:3. Compounds composed of metals and non-metals contain charged species. These charged species are known as ions. An ion is a charged particle and can be negatively or positively charged. A negatively charged ion is called an anion, and positively charged ion is known as cation. For example, sodium chloride. Its constituent particles are positively charged sodium ion Na+, and negatively charged chloride ion Cl-. Ions may consist of a single charged atom or a group of atoms that have a net charge on them. A group of atoms carrying a charge is known as polyatomic ion. Till now, we talked about different types of molecules. Now, let's have a look at how can we represent these molecules in notations. These notations are known as chemical formulas. The chemical formula of a compound is symbolic representation of its composition. The chemical formula of different compounds can be written easily. For this, we need to learn the symbols and combining capacity of the elements. The combining capacity of an element is known as its valency. Valency can be used to find out how the atoms of an element will combine with the atoms of another element to form a chemical compound. The valency of the atom of an element can be thought of as hands or arms of that atom. For better understanding, we can visualize as human beings has 2 arms and octopus has 8. If one octopus has to catch hands of a few people in such a manner that all the 8 arms of octopus and both arms of humans are locked, there should be one human hand for every octopus arms. Hence, there should be 4 humans to lock all the arms of one octopus. If we represent the octopus with O and human with H, we can write the formula for this combination as OH4. The subscript 4 indicates the number of humans held by octopus. In chemistry, there are certain rules to write a chemical formula everyone has to follow. The rules are: the valencies or charges on the ions must be balanced. When a compound consists of a metal and a non-metal, the name or symbol of the metal is written first. For example, calcium oxide CaO, sodium chloride NaCl, iron sulfide FeS, copper oxide CuO, etc., where oxygen, chlorine, sulfur are non-metals and are written in the end, whereas calcium, sodium, iron and copper are metals and are written in the beginning. In compounds formed with polyatomic ions, the ion is enclosed in a bracket before writing the number to indicate the ratio. In case of the number of polyatomic ion is 1, the bracket is not required. For example, NaOH. While writing the chemical formula of compounds, we write the constituent elements and their valencies first. Then we cross over the valencies of the combining elements. For example, hydrogen chloride. To write formula of this compound, first we have to write the symbols of constituent atoms, which are hydrogen and chlorine. Then their valencies just below the symbols, which is 1 for hydrogen and 1 for chlorine. Now we have to cross write the valencies in subscript with another atom of the compound. And this is how now we get our formula, which is HCl. Second example is hydrogen sulfide. To write formula of this compound, first we have to write the symbols of constituents atoms, which are hydrogen and sulfur. Then their valencies just before the symbols, which is 1 for hydrogen and 2 for sulfur. Now we have to cross write the valencies in subscript with another atom of the compound. And that is how we got our formula, which is H2S. Third example is carbon tetrachloride. To write formula of this compound, first we have to write the symbols of constituents atom, which are carbon and chlorine. Then their valencies just before the symbols, which is 4 for carbon and 1 for chlorine. Now we have to cross write the valencies in subscript with another atom of the compound. And that is how we got our formula, which is CCl4. Fourth example is magnesium chloride. As we can see, there is a metal magnesium and a non-metal chlorine, and they have charges over them. Magnesium +2 and chlorine -1. To write formula of this compound, first we have to write the symbols of constituent atoms, then write their quantity of charges just below the symbol, which is 2 for magnesium and 1 for chlorine. Now we have to cross write the charges in subscript with another atom of the compound, and that is how we can get our formula, which is MgCl2. For more information about this or any episode of the series, check out the blog. Link is in the description. We have additional contents for the readings and transcripts of every show. If you value the show and educational resources and wanna help keep it going, subscribe the channel and also subscribe our blog. Or alternatively, you can like, comment and share the show. It may be just a click for you, but every little bit adds up. Thank you for coming to the channel and watching the video. I hope you loved the show.